Welcome back, guys, to OpenGL Part 2. My name is Matt. You're watching Code Tech Tutorials, and we're going to jump right into the code and start doing some more stuff. So since last time, we've made some changes, and I'm just going to show you those and all that stuff. Don't forget to like, comment, subscribe, and if you want to support further, you can join the Patreon, which will all be linked down below, along with this source code. And let's get into it. I hope to elucidate all these OpenGL things as we go. Some people have expressed some concerns of why OpenGL. Well, there seems to be a lot of demand for it, and I want to do it in my own way. A lot of the tutorials out there are just tutorials of other tutorials, and I want to do things a little differently and break down how I understand it. Maybe that will help, and I'm definitely going to try to deviate from the other stuff, at least a little. That way we get some original stuff. All right, so for this update, since last time, here's what we're going to be doing. We're going to be uploading meshes. This will be to the graphics card for OpenGL to render, and we're going to be rendering meshes, and we're going to be also unloading meshes. So if you want to like switch levels and switch scenes and stuff, switch assets, you definitely got to unload the old ones. Otherwise, you're going to have just tons of space taken up for no particular reason. We're also going to be doing some keyboard input stuff, and we're going to be looking at the viewport size and the frame buffer resize. So those are the main things for this video. So to upload a mesh to OpenGL, you need to have a list of points, and I'm doing that by making this vertex structure. So one thing we did is, and if you're following along, you want to add a file called vertex.h, and this will hold a struct that is just a vertex. Right now it only has a position, an x, y, and z, and a constructor so that you can set them as you create them. But we will be adding to this later. This is basically our placeholder for our vertex data, and to get started, position's good enough. And we also have our draw details. Now this is specific sort of to the rendering. I decided to keep it in this file as well because, I don't know, it just seemed like it fit here sort of. But this is basically what OpenGL needs to know about to do its rendering, and there's a VAO, which is a vertex array object, and the number of elements. So those are the main things we're going to be using. So these are just two structs that we're going to be using throughout to help handle our data. We're not going to be using GLM. Well, a lot of people do use GLM, but I'm going to skip over that, at least for now. We might start using it later if we need to, depending on what how deep we go, because some of the math that they abstract is really nice, and I don't really want to have to rewrite that. But for now, instead of a vec3, we're just using a float array with 3. And we're going to do that quite a bit. It's just easy to handle that data. Okay, well, let's just go to our source file here. And we'll start from the top and kind of walk through it here. So I did add a clear color. This just sets the background to something other than black, which is what it was before. And I am just creating a vector of vertexes. And that's essentially our object, is just a bunch of different points. Each vertex is a point. This is 3 points, and it is enough for a triangle. So the OpenGL screen is from each corner, -1 to 1. So it's basically 2 units across, because it goes from -1 to 0 in the middle, and then to 1 on the other side. So with these points right here, and just using all the default shaders, we're using 0.5 because that'll go about halfway across the screen. So like this point, for example, is 0.5 on the X, so it's over to the right, about halfway, and then -5 on the Y, so that it's down. I'm not sure this is going to look right on the camera. It might look opposite, but you'll get the point. So, pun intended, maybe. All right. And so these are just the 3 points of a triangle, one on the bottom right, one on the bottom left, and one in the top middle, and we'll just see a little triangle. And then we also want elements. Now, this is really a optimization. When we're rendering, you can have an element array that tells which points belong where, basically. It tells you the faces. So every 3 of these is a face. Now the reason we want to do this is because sometimes you want to share points. Like when you're making a square, for example, you do it out of 2 triangles, right? Let me just draw this. Okay, so just a quick explanation here, just to give you a little data in case you don't know this stuff. Say this is your computer screen. I know it's all black, but pretend it's your computer screen. And you pop up an OpenGL window. Looks something like this. Boom. There. Say that's our window, and that's our little screen space right there. So of course we would have the points, as I said, right in the center is 0, 0. For X and Y, and down here is like -1, -1, and up here is 1, 1. So we're picking points right there, and right there. And with those 3 points, that makes a triangle. So that's essentially all we're doing in this tutorial. Now, the element buffers that I was talking about is another thing. So if you want to draw a square, usually you draw like a point here, point here, point here. Pretend those are lined up better. And you draw this one, and then you do, make this another color. And then you do like point here, point here, point here, and draw another one. And it essentially makes a square. Pretend that's a good square. I know it looks bad. But the point of the element buffer is you can reuse these right here. And without the element buffer, you have to declare them again. So any points that overlap like this with the element buffers, you can just say, oh, just use that one again, because these say where to index. So the 0, 1 will be the very first one. This will be the second one. There's only 3 because it's a triangle, but if we added a 4th one and wanted to make it a square, we would add one more of these and then just expand this one out. It would be something like, well, we use 1 and 2 again, and then we'd introduce one more point. So it would be like 4, 1, 2. And while we're drawing 2 different faces with points, we still only have 4 points. These are wrong for the square. I'm just trying to make an example for the future. So that's the whole point of these element array buffers. So we set up our data here on the C++ side, and then we send it to the graphics card. And that's what this upload mesh function does here. So I've created this upload mesh function that takes a vertex or a vector of vertexes and a vector of unsigned ints for the elements. So you pass those in after you create them. You can also bring these in from 3D models. So if you're using 3D modeling software and you export it, you can use some kind of importer, get the points, get the elements, and upload them with this same function, and it will work at a very basic level. And then this R draw details, we're just making a vector of draw details. There's only going to be one in here, but this is, I'm making it in a way so that you can add more than one to it, because later when we go to draw, we pass in a vector of details and it basically renders all that stuff. So let's go ahead and do this upload mesh function. I'm going to talk about it real quick. So I did create a folder called rendering, and in it I put OpenGL draw.h and OpenGL loader. So this upload mesh is part of the loader. Let's go ahead and look at that. And you'll see there's 2 different functions in here. There's a upload mesh and there's unload mesh. And now that I'm looking at it, I realize how close those names are. So it's maybe not the best naming scheme, but you can tell them apart, because the upload mesh takes more stuff and it returns draw details. So when you call this upload mesh and you pass it a reference to your vertexes and a reference to your elements, and then it just makes sure those aren't empty, because we don't want to have empty arrays of either of those for what we're doing. And then we go through the upload process. Now this is the process you kind of generically see on every tutorial, but I'm going to go ahead and walk through it real quick just to make sure it's all understood, because it is a little bit complicated to understand and it can be a barrier for some people. So hopefully this upcoming explanation that I do here will help someone. And that's the whole goal. This is to help people understand this. Okay, so what we're going to do here is use the OpenGL library to push stuff to the graphics card. So all these functions are abstracted from OpenGL. They've already written all the hard code to do all this stuff. All we got to do is call them in the correct order, basically. So I'm going to explain them now. All right, so first of all, we're going to just hold a few identifiers, and you'll see why we need these in a second. Some of these are temporary. The only one we're going to save is the VAO. These others are just placeholders for now. What we do here, and I'll go back to the drawing board real quick. Let's just make a new one. So what we do here is we make a VAO, and a VAO, it's basically a matrix. And you should know what a matrix is if you do coding stuff. It's just multiple arrays. Well, it starts out with just nothing. You declare it and it's just like an empty one. But what we're going to do is we're going to bind this VBO, which is a vertex buffer object, which is part of it. So this whole thing's a VAO, but we're going to have little parts of it that are like a VBO. And we're also going to make another little part of it later called an EBO. And you can expand it further, but our VAO is just going to have these few things for now. And these are basically just arrays of data. This VBO is going to end up being all our positions. And if we expand those vertexes later, it will include more stuff in it too. Like maybe it'll be positions, normals, texture coordinates, and all of that. But for right now, it's just going to be all our positional stuff. And we'll talk about more of it later. And the EBO, or element buffer object, elements and indexes or indices are used interchangeably. They all mean the same thing, basically. OpenGL calls them elements. This is just going to be an index. It's just going to be a bunch of unsigned ints. The VAO is going to hold both of these, is the whole point. And yeah, that's basically how it works. So first of all, we generate the vertex arrays for VAO. And this returns an ID for this VAO. So after calling this gen vertex arrays right here, our VAO now has an ID, and it's not 0. And then we go ahead and bind the one we just created. Now binding basically means you're working with that one. So when you bind it, you are now working on that one. So your next calls or your next stuff will all work on that VAO. So now that we're on that VAO and have it bound, we're going to generate some buffers for a VBO, just one. And we're going to bind this VBO as an array buffer. And then we're going to buffer data. And this buffer data is what actually does the send to the graphics card. So when we buffer it, we tell it what type. It's an array buffer. Then we also have to do the size and memory. Let's see if I can hover over this and get a little call out. Okay, well, this is the size and memory. And you can get the size and memory by doing the size of this vector. So it's the verts.size. So if there's like 20 of them, it'll be 20. And then we got to times that all by the size of each vertex. So this size of will return you how large in memory a vertex is. So for each one, we just times it by the size of it basically, and now we have the size of all that data. And then we want a pointer to the start of the data, and you can get that when using a vector by using the .data. You could optionally, if you're doing it with an array, and vectors are arrays, the .data just gets the start of an array. You can do it something like this too. You see this a lot. Which is just a reference to the first element. That's also a pointer to the start of the array. But we're going to stick with verts.data here. And then we're using static draw because we are not going to change these points once they're uploaded. So we call it static. And that's generally what you're going to be using there. And then we will be transforming them at some point, and that is different from changing the points up there. The points on the card stay the same. All right, and next we enable these vertices basically. So we want to tell it GL vertex or trib pointer, the 0th one, so the very first one basically, it's 3 elements. And that's because it's a position, it's an X, Y, and Z. And it's also a float, it's not normalized, and it wants the size of each individual one. So it's just the size of a vertex, the size of each individual set of positions. So the size of a vertex, this vertex is a struct that, we looked at it earlier, but all it holds is basically this right here. So the size of it is just going to return the size of 3 floats, essentially, since that's the only thing in the struct. So the size of each of those 3 points is the size of a vertex. That's basically how that works there. And now here we have an offset. Now, This basically wants a pointer to the start of the data. So to get that from a struct, you can use offset of, and then pass it your what struct object, and then the name of the member. Yeah, member in the struct. And then you want to cast that to a const void star. So you can use offset of if you have multiple pieces of data in there. Like for example, if we eventually have a texture in there too, we would use the same offset of and just put that in there like that. And we'd have to adjust everything else, but it'd be like the next one. We will get to that. We're just not going to do that in this tutorial. Right now, we're only working with those positions. And then you need to enable the trib array by saying enable whichever one it was. It's the 0, 1, enable it. So now that's enabled on the VAO. And that's all done. We're done with those points. Now we just want to upload these elements. And you do that in a very similar way. You generate a buffer for the EBO, then you bind it, and make sure you bind it as an element buffer or element array buffer. And then when you buffer the data, you also got a dual element array buffer. That way it knows. And also the size of it is once again going to be a very similar thing. It's just the size of the vector times the size of each data member. And then we get a pointer to the start of the data. It's also static draw. And then we're essentially done. But one thing you want to do at the end just to clean up is bind vertex array 0. That is like the default one, because up here we bound our VAO, which is not 0, and we worked with it. But once you're done working with a vertex buffer, you want to bind 0 when you're all done. That way you don't mess up something else later in your program. It's just good practice. And then we're going to delete the VBO and the EBO because we don't need them anymore. They're already all set up. The trib pointer is all set up and it's enabled. And the EBO is there as an element array buffer. It knows how to use all that stuff now that it's all uploaded, so we can delete those. We do need to save this VAO, so we're not going to delete it until we're completely done with the data. So we're going to go ahead and just return the draw details. And so to draw later, what you're going to need to remember is the VAO and the size of the elements, because that's, you want to tell how many to draw. So that's what we construct there with draw details and then return to the user. And you see this is just a struct and it has 2 unsigned ints. And it's something we could expand later if we need to. And that is it for the upload mesh. So now that we have it uploaded and we have returned a set of draw details, there's now one thing in our vector here of draw details. And we continue on and we enter our while loop. So when we go into our while loop, I went ahead and added a process input function. I just put that in the new file here called input.h. So you'll need to create an input.h if you're following along. And all this is a static void process input that takes a window, GLFW window pointer. And when you call this, it just checks if a key is pressed, and you can make this whatever key you want and do all sorts of stuff here to your program. But the only thing we're going to do is check for a press of escape and set the window that it should close to true. This doesn't actually close the window. It just says, hey, the next time you check, this window is supposed to close. And that's for us to handle, and that is what we handle right here in this while loop at the top. So if you press escape, the next time it tries to start this loop, it's going to say, oh, we need to close, just continue on. And once it gets to terminate, it does actually finally close, but we'll talk about that here in a second. So we process the input. You won't have any input the very, very first run, but you'll get it real quick because at the end of every loop, we poll for events again, and the start of the next one we process. All right, so what we do here is a GL clear on the color buffer bit, and this will set it to whatever color you have set on this GL clear color. And we want to reset this every time before we render. That way it goes ahead and sets the background. If you don't do this clear, everything just starts stacking on top of each other and never clears, and it's just, your screen becomes a mess. So you got to clear before every draw. And then we draw using our details. Now if we go ahead and take a look at this draw function, I put it in this OpenGL draw.h under the rendering folder. And all it does is, as you can see here, it takes a const reference to our draw details vector. We only have one thing in it right now, but if you want to make a bunch of different objects, and put them all in here, it'll just go through and render them all. So it's just something that's easily expandable so that you can draw scenes later with this sort of function. And something you can keep expanding on. That's one of the points I kind of want to reiterate as I go through this tutorial is often we want to design things in a way where it's expandable later. So I'm trying to explain it in a way where you know or kind of have an understanding of how to expand it. And that's a thing I think a lot of other OpenGL tutorials kind of don't really talk about or lead on towards, and something I want to do differently. So let me know what you guys think about that. Okay, so anyway, we just iterate through every one of our details. And for each one of them, we bind the VAO. So we're working with that one. And then we call draw elements as triangles for however many elements. And this is an unsigned int. And null pointer just means at the start of our elements. So you can change this final thing to say, oh, only draw like the second half or some middle portion of my elements. It's kind of a niche thing to do. Usually you want to draw them all if you're drawing, but there are some weird optimizations people do with this. So this draw elements works specifically when you're uploading with the element array method, and that is standard. If you export an object from anything, it always does it with the indices or elements because it's more efficient that way. So a lot of tutorials teach you how to do it with just points and don't even talk about elements. And then after doing that, they say, okay, now here's how you optimize it. So I'm kind of skipping over that point, just FYI, and I'm going straight to the elements. Okay, and that's all that does is it binds and draws every one that we have set up. And then when we're all done, after we're done with that for loop, we once again bind vertex array 0. This is always good practice. If you're binding somewhere, when you're all done, bind back to 0. Okay, so that handles drawing. Now, the thing about drawing is it draws to your back buffer. You don't actually see it until you call glfw swap buffers, because that'll swap whatever you're drawing to the front. And then the pool events is just a glfw thing to check for all the key presses. And then on the next loop, we'll process those, and that'll just continue. It's not actually going to do anything because it's just, it's just an object on the screen. And then when we're all done and we leave, we just call unload mesh on all of our draw details. So this is another function I made in the OpenGL loader, just called unload mesh. And all this does is it just goes through all those details and deletes every VAO that we've created. And then it also clears our draw details with details.clear. So this unload mesh is pretty destructive. It destroys, everything on the graphics card that you had uploaded from these draw details, and then it clears the vector. But that's what you want to do when you're all done with it. And you might have them sectioned off, if you're doing like a game or something, you might have like, oh, here's all like specific elements for just level 3, for example. And when we're all done, we want to unload all those elements for level 3. So you typically won't have one giant array of everything. Usually you'll have them sectioned as like, here's objects that only render when you're really close, and here's one, stuff like that. There's a lot of different ways to do it, and you'll have to play around with optimizations depending on how your stuff is structured. But that's like a broad overview there. And then, of course, after we're all done with that, we just call glfw terminate. Now, it is notable because someone might eventually say something like, you don't need to do the delete thing. Well, no, you don't, because you're just leaving the program, and it's going to, clean up after itself when you completely leave anyway. But it's just good practice because it's something you need to know. And if you're doing graphics, at some point you're going to be wanting to like switch levels or load different things as part of your. It's the old static single window thing is only the hello world. It's when you're really getting in, digging in. Yeah, you're gonna be doing all sorts of neat stuff. And another thing we did, which I haven't mentioned yet, is we set the frame buffer size callback. And so all this does is it helps adjust the size of our viewport. So when we first launch our window, let's go ahead and launch it now. I think I've said enough. And there it is. So there's everything we set up. Now, let me just show you this function here. So there it is. All it is a function. It's got to be of this signature. It takes a glfw window pointer and a width and a height integer. And you can do whatever you want here, but the only thing we really need to do is just call GL viewport 0, 0 and the new width and the new height. So when you set this callback, GLFW, the frame buffer size callback, anytime you resize the window, it calls this function. So I'm just going to show you without it what it does. We resize our window, our viewport stays in the same place, which is just the bottom left, and it also stays the same size. Set frame buffer size callback and change the GL viewport. Now 0, 0, these first two numbers, it's just the bottom left where you want the bottom left to be, and 0, 0 is the bottom left. Now this viewport space is different from the OpenGL space that I was talking about before. Say, for example, this is your screen. And in OpenGL space, which is like the model or world space, 0, 0 is in the center. But in viewport space, 0, 0 is at the bottom left. So it's like right here. So it'll be like, okay, there's 0, 0. And then you set the viewport size to whatever you say the width. So it just starts at 0, 0. It's not really that big of a thing. It's just something you kind of need to be aware of. Otherwise, you're just going to get confused at some point. And that's it. That is all the code. Let me know what you guys think. I'm always reading and listening to you guys. I'll see you in the next episode. Peace out.